Hello friends, today we will see how to draw a cycloidal curve. This comes under unit number 3, that is engineering curves. First understand what is cycloid. It is defined as the locus, or you can say the path, traced out by a point on the circumference of a circle which rolls along a straight line without slipping. You can see here a circle is rolling on a flat surface and they have considered a point on the circumference of the circle, and for that point they have traced out the path. So same way we have to draw a cycloid for a circle rolling on a flat surface without slipping for a one convolution, that is one revolution. So let's start with the question. So here they have mentioned a 40 mm diameter rolls along a straight line without slipping. Draw a curve traced by a point on the circumference for a one complete revolution of the circle. It means we have to draw a cycloid for the one revolution of the circle. So let's start with the step number 1. First we have to draw a circle for the given diameter, that is 40 mm diameter. So radius becomes 20 mm. Now after drawing the circle, divide this circle into 12 parts. Even 8 parts is also okay. So more number of parts, so more accurate curve. Hence we are going here with the 12 parts. To understand how to divide a circle into 12 parts, refer videos from the unit number 1, that is a geometrical constructions. After drawing circle and dividing it into 12 parts, now draw a horizontal line and it must be a tangential to the circle starting with the point number 0. So you have to draw a line horizontal as well as tangential to the circle through point 0. Okay, and length must be equal to the circumference of the circle. See, the question is based on the one revolution of the circle. So during one revolution of the circle travels certain distance, and that distance is equal to nothing but the circumference of the circle. Hence we have to draw a line which is horizontal and tangential to the circle passing through the 0, and length is equal to the circumference of the circle. Now divide this line, or you can say the pi d distance, that is circumference, into 12 equal parts. Make sure that if you have divided circle into 12 parts, then this distance must be divided into 12 parts. If you divide the circle into 8 parts, then this distance must be divided into 8 equal number of parts. Now how to divide any length of the line into equal number of parts is given in the videos related to the unit number 1. Now after drawing a line and dividing it into 12 parts, now draw another horizontal lines passing through all the points. Now you can see here the angles are same 30 degree when you are going for the 12 parts. Hence one line for the 1 and 11 and extend it, then 2 and 10 single line, 3 and 9 one more line, 4, 8, 5, 7 and 6. Now extend them up to the 12 point. So you will get this kind of structure. After this, now draw a vertical line passing through the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These numbers which are mentioned on the horizontal line. Okay, so draw vertical line through all these points and extend this line up to a center line of the circle. So it gives you the center for each and every position of the circle. Okay, so this is the center for the position number 1, position number 2, position number 3 and so on. So in this way you can plot the centers. After plotting the centers, now let's consider a position of a circle at center number 1. So this is red colored circle is the position of the circle at C1. Now take a radius is equal to 20 in the compass. Now center as a C1 and draw a circle, or even if you draw an arc, that is enough. Just draw an arc or circle in such a way that it will cut the horizontal line passing through the 1 number which is on the circle. So here you can see one circle has been drawn over here, and after that this circle cuts the horizontal line passing through the 1, and I'll get the point P1 over here. So I repeat, take the radius 20 of the circle in the compass, C1 as the center, and draw a circle, or you can draw only limited arc, okay, to get this intersection. But make sure that if center is C1, then you have to cut the line passing through the 1 which is on the circle. Okay, so here you will get point number 1, that is P1. In the same way, now draw an arc or circle, you can say, at center number 2, radius remains same 20, center C2, and draw a circle. So this circle will cut what? The line passing through the 2. So you will get P2 over here. Then P3, center 3, radius 20, and draw a circle. So you will get a intersection with the line passing through the 3. So if you have taken center number 3, then it will be a line passing through the 3 only. So here we are getting point number 3. Now I'll go for the C4, radius again 20, and I'll get the intersection with the line passing through the 4. So that point is named as a P4. Now you can see here the circle has been drawn through the center C5. So intersection must be with the line passing through the 5. And the name is P5. Now here you can see center C6. Okay, and this is, you can say, the half movement of the circle or half rotation of the circle. It means what? The initial point is now at the topmost position from the ground level. So P6 must be exactly above C6. Okay, here you can check if there is any error in the drawing. If these horizontal lines are not parallel to each other, then you will not get P6 point exactly above C6. So here you can rectify your error if it is there. So one can easily understand that after the half revolution, okay, these are the 12 parts. So at 6 you can say the point must be exactly above the center. Okay, if you are starting from the bottommost point, and if you divide circle into 8 number of parts instead of 12, then 4th must be at the topmost position after half revolution of the circle. So now this is up to a half revolution, that is point number 6. Now let's proceed. Now consider 7th point. So center is a C7, radius remains same 20, and now draw a circle, or you can say a limited arc, to get the intersection with the line passing through the 7. Okay, so this is the line passing through the 7, and here you can see there is an intersection of the circle with the line number 7. So this is P7 point. Let's proceed. Now center number 8, radius remains same, that is 20 mm, and you will get an intersection of this circle with the line passing through the 8. So this point is P8. Same way I'll go with the 9th position. C9 is the center, radius is same 20 mm. Now this is the intersection of the circle with the line passing through the 9. Okay, then I'll go with the 10. So this is the line passing through the 10, and you can see here the circle is getting intersected with the line passing through the 10. So this point is P10. Similarly, I'll plot P11, and now the last point is the P12. So this is one complete revolution, means the initial point after one complete revolution reaches the original position, that is the bottommost position, you can say here. And this is the 12th position for our problem. So like C6 and P6, C12 and P12 must be exactly on a same vertical line. Here you can see the P12 is exactly below of C12. Here also you can rectify the error if it is there, because if lines are not parallel, you will not get P12 points exactly below of C12. So in this way we have plotted all the required points. We have divided circle into 12 parts, hence here 12 points, P0 to P12. Now join all the points with the smooth curve using French curve. So here you can see here, this is a cycloid starting with the P0. This is the initial position. You can see here circle, and P12 is the final position after one complete revolution. I hope how to draw a cycloid is now very much clear to you. Thank you. Thanks a lot.